Hello everyone, today we are going to see chapter 1. So in chapter 1 we are learning rational numbers. So what is rational number? If it is possible for us to represent a number as p by q form, then the numbers are called as rational numbers. And we have learnt about irrational number also. So which is opposite to the rational number. If it is not possible for us to represent the numbers in p by q form, then the number is called as irrational number. So we can have some example for rational numbers: 1 by 2, 4 by 5, 10 by 15. It will be keep on going. Right. So few examples we can write for irrational number as root 2, root 5, the value of pi, or 1.001001, etc. It will be keep on going. Right. If there is no end, it is called as an irrational number. Thus, now if you want to represent this root 2 on number line, how we can locate it on that number line? So in order to locate this root 2 on number line, they are using the Pythagoras Theorem. Right. So this is on that number line, we have to represent this root 2. So we know that the root 2 value is 1.414. Right. Okay, if it is root 2 without measuring, how can we represent it at that number line? So for that they are using the Pythagoras Theorem. So take this root 2 as the value of c. Right. We know that Pythagoras Theorem is c square is equal to a square plus b square. Right. If we square and add the two numbers, we have to get the answer as 2. So we can take the two sides as 1 and 1. So they have measured this value as, this is OA and AB. OA is 1 and AB is 1 unit they have taken. Then obviously we will get OB as root 2 units. So with the help of compass we can draw one arc from O to B. Right. We have to make sure that the arc touches the straight line. Then we will get this as the value of root 2. So this measurement is called the value of root 2 on that number line. So likewise we can represent any other irrational numbers on that number line. If it is given in root, for example root 2, root 3, root 5, right, so many values we can represent on the number line. So after rational and irrational number, right, we are having real numbers. So all the numbers together we will call them as the real numbers, both rational and irrational. Right. So then we are going to see the real number and their decimal expansion. So if we are having a number, for example, if we are having a value 4 by 3, how to represent this 4 by 3 in decimal expansion? Simple, we have to divide that 4 by 3. We will get its decimal expansion. So 3 table 4 1 times, balance 1 we will get. So this 1 won't come in 3 table, right? So we can add a decimal, then we have to add a 0, then 9, again 1, 0, 3, it will be keep on going. Right, like that we can represent the rational number as a real number as a decimal expansion. So there are two cases over there for representing the real number as a decimal expansion. There are two cases. So first case is the remainder becomes 0. When the remainder becomes 0, what we will call it as. And the second case is the remainder is not 0. The remainder never becomes 0. So we have seen an example, right, 4 by 3. So we won't get the remainder as 0, which means the number will be keep on going, right? So we will represent it as 1.3 bar. This bar represents the repetition of that number 3. So the number 3 will be keep on repeating. So this type of number is called as, okay, we will call it as non-terminating decimal. So this is a decimal number, but there is no termination for that one. There is no end. So we will call it as non-terminating. Right, whereas if you are taking an example 4 by 5, right, so if we divide 4 by 5, so we won't get 4 in 5th table, so we can add a decimal, and if we add a 0 we will get 8, so 40. So here it is 0.8. If we take a look, the remainder is 0 over here. So the problem has ended over here, it is terminated here, terminating decimal. So now we are going to check whether it is possible for us to represent the decimal as a fraction. Okay, suppose the question is 0.6 bar, so we can write it as 0.6666, etc. It will be keep on going. So we said no, the bar represents the repetition of number. So now we have to take it as x. So now we are multiplying both the sides by x. Then we will get 10x is equal to 6.6666. It will be keep on going. So we can take it as this as equation 1 and this as equation 2. Then we can subtract equation 2 minus 1. We will get 10x equal to 6.6666. Then x is equal to 0.6666. So these after the decimal, no, all the numbers are same, so they will be gets cancelled. So 6 minus 0 we will get 6. 10x minus x we will get 9x. Therefore x is equal to 6 by 9 we will get. So it is possible for us to represent the decimal as a fraction. Either it is terminating or non-terminating, we can represent them as a fraction. So next one is the visualizing the numbers on the number line, decimal numbers. Right, for example, if you are having a number like this 4.326, we have to represent it on the number line. So we have to take from 0, 1, 2, 3, 4, right? So we have to check in between what value the 4.3 will be lying. So it will be lying between 4 and 5, right? So from 4 to 5, again we have to draw the line. So we will get 4.1, 4.2, 4.3, 4.4, then 4.5, 4.6, 4.7, 4.8, 4.9, then 5 will come, right? So from now we have to check 4.3, then we are having 4.32. So now we have to check 3, 2 will lie in between what value? So it will be lying in between 3 and 4. Then again 4.31, 4.32, 4.33, 4.34, 4.35. So we have to write. Then now we have to check 4.326 we are having. So 4.326 will lie in between 4.32 and 33. So we will get 4.321, 4.322, 4.323, then 4.324, 4.325, then finally 4.326 we will get. So up to this we have to draw that line. Okay, we have to draw that number line properly, then we have to locate that number on the number. Clear? So already we have learned how to represent root to a number line, right? Suppose if we are having a value like this, root 4.6. Now if you want to represent this root 4.6 on number line, how we can represent that one? So for that what we have to do is, we have to draw a line which is AB. So without this root we have to find, so which is 4.3 cm. So first we have to draw a line which is 4.6 cm. Then we have to add 1 cm extra. So this is common for all the problems, right? That 1 cm we have to take. Then we have to find the midpoint, that is perpendicular bisector for AC. So with the help of compass we can draw 2 arcs above the line and below the line. Then we can get the midpoint of AC. Okay, we can take as O. Then with OA and OC as radius, we have to draw one semicircle. Right, after getting the semicircle, right, what we have to do is, we have to keep the compass on the point B and we have to take any centimeter. It can be 1 or 2 centimeter. If it is needed, we can extend this line. Okay, in B as center, we can draw 2 arcs along the line AC. Then we have to measure this length. Then we have to draw 2 arcs from here. From this point to this point, we have to draw 2 arcs. Then we have to draw a line which should be a perpendicular. Okay, then we have to measure this length with the help of compass. So we can mark it as B. So BD to BE we have to draw. So from B to D we have to measure with the help of compass. Then from B to D to BE we have to draw. This BE will be the length of 4.6 centimeter. This is how we can represent the number on the number line. So not only for 4.6, whatever number we are having, we have to add 1 centimeter extra. Then we have to find the perpendicular bisector. After that, from the point B, we have to draw a perpendicular line. Then we will get the length. Next comes the rationalizing the denominator. So which means we will be having some root value on the denominator, that is irrational number on the denominator. If we are. So in order to remove that one, what we have to do is we have to multiply that number by its conjugate. So conjugate is nothing but multiplying with the denominator. If it is a one variable in the denominator, one term is there, okay, we don't want to change any sign, we can directly multiply. So 1 into root 2 we will get, root into root 2, root gets cancelled, we will get 2 as the answer. Now the denominator has been rationalized. Only the denominator we have to check. Suppose if you are having like this, right, if you are having two terms over there in the denominator, then we have to multiply it by the conjugate. Here the conjugate is the opposite sign of that number. So here it is an addition, right? So we have to multiply by subtraction. So root 4 minus root 3. So 1 into root 4 we will get root 4 minus root 3. By here we are having root 4 plus root 3 into root 4 minus root 3. So here we have to use the identity a plus b into a minus b. We will get a square minus b square. So we will get root 4 minus root 3 by square and root will get cancelled, we will get 4. Here also we will get 3. So 4 minus 3, 1 we will get, which is minus 4 minus root 4 minus root 3 we will get. Here the denominator will become 1, therefore the denominator has been rationalized. Next comes the law of exponent. So this one already we have learnt in our lower classes. Okay, so a power m into a power n. If we want to multiply two base, we have to add their power. And the bases were same, we have to add the power. So for division, we have to subtract their powers. Suppose if you are having a power m into the whole power n, we have to multiply the powers. And if you are having two different bases with same power, means we can multiply the base and we have to give the same power to. That's all. Chapter 1 is over. So these are all the few things we have learnt in chapter 1. Is there any query? You can tell it in the comment box. Thank you all.